Okay, and then once we've worked out that RW is equal to 45G, we can start plugging things into this final expression. And now the beauty of us doing everything abstractly and just with algebra becomes a lot clearer. And so I can do L times 45G times, we've got mu W cos theta plus sine theta minus L on 2 big mg cos theta over little m g cos theta. And now the convenient thing is, because we're told in the question that theta is equal to 45 degrees, sine equals cosine. And so, and because if you consider each of the, I mean, there's three terms on the top here, right? But they've all got one in. We could factor out 1 on root 2, which is cos and sine 45 out of this thing. And so we cancel that and that and that and that. Also, now everything has a g in it, which is why I chose to put that 45 in, just to show that substitution to the examiner, if you will. So I'm left finally with L times 45L times mu W plus 1. That's very important. You remember the plus 1 is there from that cancellation, minus L on 2 times big M over little m. And now plugging those final numbers in, I have 45 times 7 times, well, this is 1/3 plus 1 times 4 over 3 minus, and then this is 7 over 2 times, and then big M we said was 35, or was it 70? Big M was 35, and then the little m at the bottom is all over 70. And so if we plug that into a calculator, we get 45 times 7 times 4/3 minus 7/2 times 35, all over 70. And we get the answer that x is equal to 4.25, which is the right answer. So it's a long question, and I think you certainly will be able to do this a lot faster with a lot of practice. It's a very ugly question, but in the end, with a little bit of just assertion of which forces are acting, being tidy with our algebra, doing this little bit of simultaneous equations here, and then tidying it up at the end, it's not too bad. And in all honesty, in an exam, I'd be surprised if this wasn't worth more marks, because you're not likely to have as nice an angle as 45 degrees. If this was, say, 30 or 60, you'd have a little bit more algebra to do at this stage, and it might be worth more marks. But it's a fun question. And as mentioned, the other one we did were in the end of the tutorial, if you were there, where I said the angle was 30 and I made up some things. If we look at this system here, this function here, I mean, it's a confusing one, but it's very possible that this is less than 0, right? It's not an increasing function. You know, physics doesn't conform to maths, right? Like, maths doesn't conform to physics, so to speak. Or we can have systems that are aphysical, that don't exist physically. And in fact, the system I made was already in equilibrium before we added this extra mass. And so we're asking a question, at what point do I need to add an extra mass to already, make the system be in limiting equilibrium? It's not worth thinking about. Whenever you get a question in an exam, it should work out nicely like this in the end. But yeah, so that was a fun question. Hope you enjoyed it.